Okay, so this is the second part of AP Stats 4.1 notes. We're just going over a few more of the sampling types that we have. So systematic random sampling is the last one that you'll probably get asked relatively frequently. It is a type of convenience sampling where you ask like every certain number of people. So let's say every fourth person that walks through the mall, every sixth person, every sixth house, something like that. They can even do a randomizer to decide who's the first customer that they're going to ask, and then they'll do every fourth from there, or what's the first house they pick, and then every sixth from there. And keep in mind, though, that it is still not as good as an SRS because not everybody has the same chance of getting selected. So if you're picking every fourth customer, that fifth customer has absolutely no chance of being selected. Okay. All right, so next one is a one-stage or a two-stage sampling technique. One stage is just another way to kind of say cluster sampling. It's once a method is chosen, every individual in that group is chosen. It's just one stage, just one thing is being done. Two-stage is when you're doing two different things. So once we do one method, we're going to do a second method after that. So it's kind of like almost like an outline form where the first stage is the first thing you do, and then after you finish that stage, you go on to the second stage. So you could do any two things together. You know how a cluster is supposed to pick everybody in that cluster once they're selected? Well, you could do a cluster and then decide to do an SRS out of that cluster. Or you could start with a convenience sample, get 50 people together, and then decide that you're going to pick every third person, something like that. Okay. Again, these are not as good as simple random samples because everybody still does not have an equal chance of getting selected. Once that cluster is selected, then no other cluster can get picked, right? All right, another one that you might hear about, our book does not discuss it specifically, is snowball sampling. Snowball sampling is when you're trying to reach a really, really small group of people. So let's say we're trying to find people who have recovered from a very, very specialized, very rare type of cancer. So I might be able to find one or two of them, but I would be better off trying to get other people by asking the one or two I know if they know other people, if maybe they're in a group that that talks to other people. So that's called snowballing, where you start with a few people and then you ask them to bring more people into the group to sample. So that's kind of like a voluntary sample in a way, but it's snowballing because you're letting the existing members of the group bring more members of the group in there. Okay. And then some generalizations to keep in mind. And these are mainly generalizations, about this one word here. It's about whether you randomly sample or not. So if you do not randomly sample, then you can only generalize about the population you sampled. Okay, so if you only sampled from this class, girls with long hair, then you can only generalize about the girls from this class with long hair that were sampled. Okay, in the next one, it says if you only sample two-bedroom apartments in your city, then you can only generalize about the two-bedroom apartments in your city that you sampled. Right, so basically you can only talk about the ones that you actually looked at. However, if you randomly sample from the class, same idea again, girls with long hair, then you can generalize to the population that you sampled from. So the biggest group that we had is from the class. So then I could generalize to all girls with long hair in class. Okay, and then in the next one, if we're doing the two-bedroom apartment example, the biggest population I get is the two-bedroom apartments in my city, so then I can generalize it to all two-bedroom apartments in my city. Okay, so it's like going up one level from where you were before, from what you sampled from. Okay, all right. Last couple things that I want to put on here for you to write down along with me would be to keep an eye out for this idea of bias. We talked about it in our last notes a little bit, that one of the questions we like to ask is that you should be prepared to describe whether the bias created an underestimate or overestimate of what you were measuring. So let's say I was taking a voluntary sample. No, let's do one where we're doing, we're stopping in somebody's house and we're going to ask everybody, the first person who answers the door. Well, that's going to be under coverage, right? Because there's other people in the house that I wouldn't see. So if what I'm measuring is under coverage, right, then I'm going to probably have an underestimate of whatever it is that I'm trying to record. Okay, and let's say that typically it is the child that, I don't know if this is true or not, but let's just say it's the child that always answers the door. Well, then maybe I would have an overestimate of my sample of children. And then it would be an underestimate of adults at home. Okay, so you should be prepared to talk about whether you have an over or underestimate once you create your sample. So it depends on what I'm trying to get from there, right? If I was trying to get, let's see, the number of video games sampled, then I probably would have an overestimate by asking the kids who answer the door, since kids typically answer the door first. Okay. The other thing you want to be very sure of is that you know the difference between your sample that you collected and the population you collected it from. Okay, make sure you know those two differences, population you collected from. All right, and that's it for today. Bye, guys.